I want to give a little bit of advice for those who don't have much experience with Equation Editor. So if you're comfortable with Equation Editor, that's great. Go for it. If you have another equation writing tool, there are so many things out there. There are probably some different ones for Macintosh computers, and LaTeX is a popular one for people who do this a lot. So if you have another tool, that's great. But if you don't, and you don't have much experience with Equation Editor, I'm just going to show you in a few simple steps the extent to which I'm going to ask you to use it. And once you get the hang of it, once you write one equation, it's really easy. It just can take a little bit to figure out where you need to click and what you need to say. So let's just do a basic theoretical model, the kinds of models that you'll see in your text that I write on the board a lot, that I'll ask you to write. And that general theoretical model, if I weren't using Equation Editor, in words might be something like y equals beta. Maybe I find the symbol for beta, or maybe I'll just do something like this: beta 0 plus beta 1 times x1 plus some term for the error, something like that. That's fine. You can go look up all these symbols for these things. I just put in a B and an E, but it looks a lot nicer, and you get a lot more control over what you want to say, especially if we do more complicated things than this, if we use the Equation Editor. So let's not do things that way, and instead, to get to the Equation Editor, it's under Insert, and it's all the way at the end here. It has preset equations, like different math functions built in. Things that you'll be using are not in here yet. It doesn't have statistical things. These are all very specific math equations. So you can just click on the pi symbol, and it gives you this little box, and you can start typing. The moment you have an Equation Editor box open, it gives you all these features and all these functions. And I'll let you play around with this. You can see that you can insert different fractions. You can insert different superscripts and subscripts, and they have some common ones in here. If you want to do a square root or a cubed root, that's in there. Some calculus things. Really, all you're going to be using are the fractions sometimes, maybe, but really it's just going to be the script here, sub or superscript, and then the accent, and then otherwise you're just going to be typing in here. So for example, a general equation might be y equals, and now I want to type in a beta, because we use Greek letter beta for our generic population intercept. All those symbols, and more symbols than you need, are all over here, and beta is always just down here. The way I like to do this is to click on the symbol I need, beta. Now I want to do a beta sub 0 to show the intercept. So I like to just highlight the thing I need, and then what I want on it, I go up to the script options, and then I click the one I want, because I want a subscript of a 0. And there we go. So now I can go into my beta and add a little 0. So that's a good start. Of course, you could always, if you know what kind of thing you need in the equation next, you could always predict and fill in after the fact. So I know that I want to have a beta 1, so I might click on the same thing, this thing here where I have some term and some subscript, and just click on that. Now I have two boxes I can fill in. I know I'm going to do a beta, and I know it's a beta 1. And at this point, all I need to do is add an x. If you want to add a star for times, you can. I think this looks pretty clear as well, that it's beta 1 times x. If it's just x as your variable, obviously this is generic, you can leave it if you want to make it x1. Again, I like to highlight the thing I want to adjust, and then I go up to the script that I'm going to use, and again, I'm going to be using this one here, and then do 1. Now I'm going to add a plus sign because all of our theoretical models need an error term, and there are a few different variations of the Greek error term E, the epsilon, but I like this one. And for just a generic model, that's it. Now I'm going to show you the beautiful thing. You just wrote this equation. Well, I wrote it, but you'll write your own. If I need to do this again, or let's say I actually have variables here, like for example, let's say I have price, and let's say I have square feet, and I want to put them into a theoretical model here like you're doing for your homework and for the activities. Well, I can just copy this. I did a Control-C, Control-V, and I can just go in and change these things to what I want them to be. And since I'm just doing square feet, I'm not doing x1 or any subscript here, I can just delete that whole term and type in square feet. And that is to the full extent of a theoretical model. And one other little thing I'll show you is if you want to add like a square, like if for some reason it was this term was squared, you can just go back into the script and see that, oh, I've got a superscript option up here, and I can do something like that if that were the model we were running. But that's not the model I'm running, so I'm going to delete that and just type in square feet. And really the only other thing missing is how to put hats on things. And why do we need to put a notation for a hat on something? Well, remember, these are just our theoretical models for the population. When I ask you to do an estimated model, what I want you to do is put in, get that out of there. What I want you to do is actually put in the numbers that correspond to beta 0 and beta 1. Because remember, when we run our model and look at our output, we want to know what the intercept is, we want to know what the slope coefficient is, and we want to put this in our model. So just for example, let's say that it was negative 30,000. Great, that's my intercept. Let's say the slope coefficient was 120. Now, again, if you don't think this is very clear, you can just put in a multiplication sign. Now, there are two things I need to do here to make sure that this is showing an estimated model and not the theoretical model. When I'm doing an estimated model, I like to just get rid of my error term. And so to show that I am predicting an estimation, getting a predicted value, we have to put a hat on our dependent variable, our response variable, price. Anything that does not have a hat on it is being listed as the true value out in the universe. Since we run a model and it's estimated, we have to put a hat on this price here because that's what we're estimating. And to do that, it's under the accent option. And it's just this one over here. You can see there are all kinds of accents here, all kinds of different shapes and symbols. So just put the little hat on it, and there it is. Now I have an estimated model of price as explained by square feet with a hat to indicate that it is estimated. Now, as you might have observed, we can write this a different way. This is the estimated model, but I know that I can get back to the actual price in my data by adding in the residual. And this is all Chapter 1 material. So I can have my estimated model here, which is great. But if I add the residual back in, I no longer have an estimated price. I have the actual price. And I'm going to delete the hatted term and just add that back in. So these are both equivalent ways of writing out the estimated model. The most common way is this way, is to not put in our thing for the residual and then just say, hey, here's my model with my numbers and I'm estimating price, average price. And that's it. And again, once you write this thing once, you can just copy and paste it however many times you need for wherever it's requested. And you can just use it wherever you need to. But hopefully this will save you some time so you don't have to spend hours clicking around trying to figure out how to get this set up. Great. Let me know if you have questions about this, and good luck.